Greetings, class. We're going to be looking at Chapter 8, Section 4, Testing the Difference Between Proportions. We'll be using the two-sample z-test for the difference between proportions. So we're going to assume that there are two populations that have proportions P1 and P2. We will use a sample from each population to test the claims about those population parameters, P1 and P2. Now, we have the same three sets of null and alternative hypotheses that we've been using in sections 1, 2, and 3 of Chapter 8. The only difference is we're looking at population proportions as opposed to the mean. And again, when you do your homework in my math lab, you're going to be writing your null and alternative hypothesis in these forms, one of those three forms. But in StatCrunch, you're going to see them in this form where they look at the difference between the proportions for the two different populations. Now, there are some conditions that have to be met in order for us to run a normal z distribution for critical values, and that's that the samples are randomly selected, the samples are independent, and the samples are large enough to use normal sampling distribution. That is, N1 times P1 would be greater than or equal to 5, and N1 times Q1 would be greater than or equal to 5. Remember where Q is 1 minus P. The same thing would have to hold also for the second sample. N2 times P2 would be greater than or equal to 5, and N2 times Q2 would be greater than or equal to 5. So what we're going to focus on today is looking at how to use StatCrunch to do these tests. So I'm going to go to page 451 of your e-text, and we're going to look at a couple of exercises there. The first one we're going to look at is number 4 that says the claim is P1 is less than P2. So the population proportion for group 1 is less than the population proportion for the other group. And your level of significance is alpha equals 0.05. And your sample statistics are X1 equal 471, and N1, that's your sample size, equals 785. And X2 equal 372, and N2, the sample size from your second group, is 465. Now, we can use a normal sampling distribution if the samples are random and independent, which they gave us, and if N times P is greater than or equal to 5. So what you have to realize here is that P, for our sample, we'll just call it P1, would be equal to X1 divided by N1. Now, if you took that p-value and you multiplied N1 times P1, then you're actually multiplying N1 times X1 divided by N1. And the N1s divide out, just leaving you with X1. So in this case, X1 is 471. Well, that's automatically greater than or equal to 5. Now, Q1 is equal to 1 minus P1. So if P1 is equal to X1 over N1, then Q1 would be equal to N1 minus X1 divided by N1. So if we were to take Q1 times N1. That would be N1 minus X1 divided by N1, and then multiply that by N1. And what happens there, again, is that the N1s divide out, leaving you with N1 minus X1. In this case, N1 was 785. And then if we subtract off X1, which was 471, then we have a difference of, I believe, 314, which is certainly greater than or equal to 5. Now, I'm going to leave the work for Group 2 for you to look at, but the process will work the same, and you can verify that N1 times P1 will be greater than or equal to 1, or N2 times P2 will be greater than or equal to 5, as well as Q1 times N1 would be greater than or equal to 5. So they need for us to write our claims on these, and sometimes it's a little easier to do your claims if you use Word. So I'm going to pull up Word where I can type the inequalities in. So in the case of number 4, where the claim is that P1 is less than P2, I know that my claim here is H sub A. So I'm going to go ahead and type that and add it into my Word doc. So that is my claim. Now, we've determined that we can use the normal sampling distribution to test the claim. So we're going to use StatCrunch to test this claim. So I'm going to go into StatCrunch, and I'm going to determine my critical values first. So my calculator will be the normal calculator. And since this is less than, I do have a less than here. And the area for alpha, my level of significance, is 0.05. And so I'm going to click Compute. 0.05. And it says that my critical value is negative 1.6448. So I will come here and I will close that, and I will say that Z sub O, or Z sub 0, is equal to that number. And if I round it to 3 significant digits, that will just be negative 1.64. Now, since this is a less than, I know that this is left-tailed. And when you saw the graph, you could see that this area to the left is red. This is my rejection region. So when I get a Z-stat from StatCrunch, if it is less than negative 1.64, then I know that it will be in the rejection region. So this is what I'm going to look for to see if that Z-stat is less than negative 1.64. Now, your book calls this Z-stat the standardized test statistic. And this is the critical value. So if you need me to label those, this will be critical value, and this one is the test statistic. So you have to remember, I use the normal calculator, in this case the normal calculator, and then for this one I will use the proportion stat command from StatCrunch. so that you run two different tests to find these. So I'm going to run the test, stat, proportion stats. I have two samples in Chapter 8 and with a summary. So for sample from the population 1, X is 471. That is your number of successes. N1, 785, your sample size, is your number of observations for sample 1. For sample 2, X2 is 372. So that is the number of successes, your X2. The number of observations will be N2, 465. Now remember I told you that in StatCrunch they use the difference rather than what we used before in our other Word document. We used P1 less than P2 and P1, greater than or equal to P2 and P1 less than P2 for those particular So since the inequality was less than in my alternative hypothesis, I use less than on the test, and I will go ahead and store this in the data table. And you will see that your value for z-stat to 2 decimal places is negative 7.29. So I'm going to come back over here to where I typed most of this in the beginning, and we're going to check that z-stat equals negative 7.29. Now I look at my comparison. If the z-stat is less than negative 1.64, then it's in the rejection region. Well, negative 7 is certainly less than negative 1, so this one is in the rejection region. And what that means, if your z-stat is in the rejection region, then we reject H sub O. So we're going to reject H sub O for this particular problem. Now, if you'll remember, I showed you a table where that if your claim is H sub A, which ours was, and you reject H sub O, then there is enough evidence to support the claim. So if I were interpreting this, I would say, because we rejected H sub O, that there is evidence to support the claim that the population proportion for the population 1 is less than the population proportion 2. We'll continue to look at some other exercises from 8.4 in the next video.